Am I doing the intro or are you doing the intro?
You're doing the intro.
Oh,
You're on the show today.
well, good, great, grand. Hi, everyone. Thanks for joining again for our second run at this. Last month, we did this web chat with the three of us for Apollo's 51st anniversary, and we got a lot of positive feedback. It was really great to hear, so we figured we'd do it again. So I'm back with the same two that were here last time. I guess the same three of us that were here last time. And we're going to talk about Mars in the 1960s and the 1970s. A little bit of housekeeping. If you have questions, feel free to pop them into the chat, whether you're watching on YouTube, Facebook, or Twitter. I think the Twitter one works, but definitely YouTube and Facebook for sure, on the little chat icon or chat boxes that come up. And we'll answer them either as we go along, towards the end, whatever works best. So I guess to introduce myself, I'm Danny Bednar. I am a assistant professor in the Department of Geography at Western University, where I teach about space exploration. I am also an analyst with the Canadian Space Agency, and I've written with Tanya and studied under Phil, and that's why we're all here today. I'll let Tanya introduce herself next.
I'm Tanya Harrison. I currently work for a commercial Earth observing company called Planet Labs, but most of you probably know me as a Martian. I've spent the last 12 or so years working in mission ops for different NASA Mars missions, including Opportunity, Curiosity, and the Mars Reconnaissance Orbiter, and working as a scientist studying active surface processes for the most part and weather on Mars.
Okay, and I'm Phil Stooke, a recently retired professor of geography and planetary science at Western University, but still working on things even though I'm not in the office anymore. And the way things are these days, it's a good job I'm not in the office anymore, I think. Yeah, so I've been involved in space exploration in one form or another all of my adult life, really, and certainly throughout my academic career.
Awesome. Thanks, Lord. Wow. Thanks, Phil. I was going to say thanks for Lord over us that you're retired. Because me and Tanya will retire in our 160s or 170s.
Yeah.
But yes, you're enjoying it out there on the West Coast.
Yeah.
So we're talking about Mars this time, and I'll get started really with the first question. You know, we're talking about the early exploration of Mars, and which does take place pretty early in the space age, considering how far away Mars is and how hard it is to get there, and that the first object only entered into space in 1957. We'll be talking about some stuff that is only just less than a decade later, so it's pretty impressive. But Phil, for you, we enter into the 1960s. The space age has kind of started, right? Sputnik has gone up. Yuri hasn't gone up yet. The Americans haven't gone up yet, but there's objects in space. There's been a dog in space. What's the identity of Mars at that time? Where is it in the public imagination, and what is the status of the red planet?
Right. So before things start arriving at Mars and providing new information, Mars was basically an astronomical object. It was an object that astronomers looked at, and other people didn't really tend to think about very much, except insofar as the public became interested in what the astronomers were saying. And the astronomers, over about 100 years leading up to the space age, had different ideas about Mars. In particular, in the late 19th century, astronomers started observing things on Mars that they thought might indicate that there could be life on Mars. And some people interpreted that, let's say extended that, to think that there might be intelligent life on Mars, civilized beings building cities and irrigation canals and all sorts of things like that. So for a while, there was an idea that there could be not just life on Mars, but actual civilizations on Mars. And that idea kind of fell out of favor among scientists as we got more into the 20th century. But in the public imagination, the idea that there might be life and living things and civilizations on Mars, I think that stayed in the public mind. So leading up towards the space age, there's still a kind of public idea that there could be quite significant levels of life on Mars, not just a bacterium or a lichen, but actual bigger creatures and maybe even civilizations. Now that's in the public mind, but astronomers had pretty much discounted that at that stage. But then we get to the stage where we can start to send something to go and have a look at Mars, and then the ideas are going to evolve again, as we'll come to.
Yeah, and Tanya, I want to ask you, because so you're a scientist, you study Mars and you communicate that to the public. And these wild ideas we were just talking about, they stemmed a lot from the imagination of science fiction writers, but those science fiction writers were basing it on some of the earliest ideas about what might be happening on Mars, and some very famous interpretations of what was happening on Mars. How did the science at the time feed into that?
So you had some folks that were making pretty fantastical interpretations of the things that they were seeing, but they weren't trained in the things that they were looking at. So that can lead you to make some misinterpretations of the data. So Percival Lowell is probably the one that most people have heard of, where he had looked at maps from a previous Italian astronomer named Giovanni Schiaparelli, who had spent 10 years looking at Mars through a pretty primitive telescope in his backyard, making maps like the one you see here, drawing all the patterns of light and dark that you can see on the surface. And these are real features. If you have even maybe just an 8-inch telescope or so in your backyard and Mars is fairly close, you can see the types of features that Antoniadi was looking at. Oh, we lost the slide on your end, Danny. There we go. The lighter areas are places that are dusty, and the darker areas are places that are less dusty when you're looking at Mars. But Schiaparelli had labeled these things as canali, which means channels in Italian, which is something that's carved by water in a geologic sense. And Percival Lowell came along, apparently didn't speak Italian, mistranslated canali to mean canals, which by definition are an artificially constructed feature, kind of like the Panama Canal, for example. It's not a natural thing. And so if we go to Percival Lowell's maps, they're certainly not nearly as detailed as Schiaparelli's, which is interesting because he built a much larger telescope to look at Mars. So I'm not sure what happened there. But his idea was that these dark areas were vegetation, and he had interpreted that Mars was an arid desert, and there were these intelligent aliens that had built this complex network of canals to bring water from the polar caps, which we knew from lots of different types of data and observations over the years that these were made of ice, bringing that water down toward the more desert regions near the equator. As Phil said, this wasn't something that was widely accepted by science, but it did capture the imagination of the general public, because obviously who wouldn't want to think that we had intelligent aliens living right next door to us?
Right, and perhaps we could just say something about those particular pictures of Mars that we're looking at there, the drawings by Lowell. If you have a very small telescope, you won't see that. You'll just see fuzzy light and dark markings. And if you have a really, really good telescope, you won't see that either. You'll see lots and lots of tiny little spots and mottled surfaces and things like that. But somewhere in the middle, you can't see all those little dots and speckles and things clearly enough to see what they really are. And our eyes tend to sort of connect them. So really, those lines are an optical illusion. And as telescopes got better, people started to see that, yeah, they were optical illusions, and that's why astronomers gave up on those ideas. Now, these two pictures of Mars, I would say, they're quite old. Those would be going back into the early years of the 20th century. But the best images of Mars from telescopes on Earth at the beginning of the space age were not a lot better than that. And so that's startling to look back at pictures taken just before the start of the space age and realize that it wasn't much better than that people had until the spacecraft start to get there.
So these are estimated, the plates are estimated from about the mid-1950s, and this was a 200-inch telescope. So this was about as good as we were getting right around the time that Sputnik 1 and Laika were going up. So this really was the best so-called image we could have of Mars at the time. So if you rewind another 40 or 60 years, I suppose you can give Schiaparelli and Lowell a break. But yes, what they were working with was quite primitive.
Yeah, I think Schiaparelli's telescope was 8 or 10 inches. It was something relatively small, but he got lucky because Mars was pretty close during that time period when he was doing most of his sketches.
Yeah, and let's add one other comment about the astronomy of Mars. Seeing those fine lines was sort of one thing that led people to think that that led some people to think that there might be civilizations on Mars building canals. But something else that astronomers observed that is a real thing but was misinterpreted is something called the wave of darkening. What happens here is that if you imagine looking at, let's say, the Northern Hemisphere, and then this will be true in alternate seasons for the Southern Hemisphere as well, but focus on the North for a bit. The Northern Hemisphere starts out in winter with the North Pole tilted away from us. We can't see it. It's got a big ice cap, frozen carbon dioxide ice that is settled onto the surface. And as the planet slowly tilts or changes its orientation so that we move into Northern Hemisphere spring, the ice comes back into sunlight and then it starts to evaporate. Meanwhile, the rest of the atmosphere of Mars is quite dusty, so it's slightly obscuring the surface. But now all this clean gas is evaporating up off the surface and it displaces the dusty air. So around the edge of the pole, as the ice is evaporating, coming up into the air, the atmosphere is much clearer and the surface looks darker. And that darker view of the surface, a clearer view of the surface, gradually extends away from the pole and towards the equator. It was called the wave of darkening. And so what we're really seeing is just changes in the amount of dust in the air around the pole as this clean gas is coming up off the surface. But it was very easy to interpret that as due to the growth of vegetation. So if you see that the polar cap is melting and the surface around it is getting darker, and that's gradually spreading towards the equator, it's really easy to interpret that as the growth of vegetation fed by meltwater. And that's sort of, so although people had given up on the idea that civilizations were building canals, the idea that the surface might have living things, maybe very small things like little lichens or just bacteria in the surface, possibly some kind of vegetation, that was more widespread. And even at the beginning of the space age, there were people who seriously thought that we were going to find vegetation on the surface.
I mean, there was a paper published in Science, I think in 1956 or so, where somebody had claimed that they had detected chlorophyll on Mars. And I think that got a little bit of traction. It wasn't a groundbreaking paper, moving forward, obviously, because we got there and didn't find anything. But it was something that they were definitely taking seriously for a little bit. Right. So when we're thinking about the public opinion of what Mars was like right at the dawn of the space age, there was certainly going to be quite a few people who expected to find vegetation on the surface.
So, yeah, and we're going to jump into that space age now. But I actually want to address a question that I think sticks with this topic. And Tanya, it doesn't allow me to throw it up on screen. So if you want to throw up this, it's a slot. No, not that. The question from Jeff. And this is one for Phil and Tanya as well. But this is a very of all the names migrated over from these early Schiaparelli maps.
Yes, those maps, and he made a new map each couple of years or so as Mars was well placed for observation. His maps provide the names that are the basis for our modern nomenclature on Mars. The only thing that's different is that now, of course, we can see lots of craters and other features, and the craters are named, the larger craters are named after people associated with the study of Mars in some way, and smaller craters are named after small towns and villages around the Earth, just to provide a large number of those small names. Names like Mojave, for instance, the town in California, show up as crater names too. But these older names are the basis for our nomenclature for the surface of Mars now.
There's probably some that will stick out as being familiar to people, like Sidonia here. Since this is drawn through a telescope, a lot of the older maps you see tend to be upside down because when you're looking through a telescope, things are flipped. So the top of this map is actually the south pole of Mars. But, you know, Sidonia, where the famous face on Mars was found, Utopia, I think most Trekkies know that for the Utopia Planitia shipyards, but also for one of the Viking landing sites. So you can see a lot of these names have held through Hellas, Argyre, things like that, Elysium, places where we've kept all of the albedo features ported over.
Yeah, I was going to ask, because even as a non-Martian geologist, this looked a bit off. Like Sidonia looked where a few different things should be, but it makes sense now that it's upside down. Okay, so this is one part of the conception of Mars early on in the space age. Things start advancing, and we're going to jump ahead. We will talk about the Mariner program, which was the first one, the U.S. Mariner program, the first spacecraft to catch a closer glimpse at this planet. But I've often had people in the space community, people who knew space history quite well, actually mention to me or claim Viking as the first Mars lander. And I've always been quite perturbed by that. Phil, why is it not right to say that Viking was the first Martian lander? And what is the story of the glorious Soviet Mars probes?
Well, okay, so the two Viking spacecraft, people have, I think, accepted this for many years now, that in fact it was a Soviet spacecraft, Mars 3, that actually managed to land on the surface safely and survive, even if only for a few seconds, and transmit something, even if only for a few seconds. But it actually did that first. This is back in 1971, so about 5 years before Viking. So the Soviet Union did manage to land something safely on Mars. It's just that it didn't actually give us any very useful information. So you have to decide whether that makes it successful or not. I would say the landing was successful, but the operations on the surface were not.
The objective was to land on Mars, and they landed on Mars, so they were successful.
Right. Now there were two spacecraft in that year, Mars 2 and Mars 3, and Mars 2 definitely crashed. Mars 3 did manage to land.
Mars 2 was practice. They got it up way. They landed successfully. One of the weird things about this mission was there was a little rover on board.
Yes, that's right. It was so both of those landers would have carried these rovers, and there's a really nice picture of it kind of shuffling along on feet. So it's not got wheels, it's got feet, and as those feet are sort of carried around by a little rotary device, they plunk down on the ground, lift the rover up, push it forwards, then drop it down again, and so it goes along like that. Oddly enough, there's actually a design for a moon rover by a Russian team that was being developed for the Google Lunar X Prize many years later that used exactly the same strategy.
How did the size of this rover compare to Sojourner?
Oh, this is really quite small. I'm not sure exactly what the dimensions would be, but I would probably have said it was only about maybe let's say 15 to 20 centimeters long. It's a lot smaller.
Oh, wow. Okay.
And it had to be because the Mars 2 and Mars 3 landers were very small. They were only about maybe 60 centimeters in diameter, spherical things. There wasn't much room for anything inside them.
So you wouldn't be able to claim that the Soviets had the first Mars lander or Mars rover. Well,
it wasn't deployed.
But it was on the surface.
I guess it was. We don't know what condition it was in, but yes. The thing is, the rover didn't operate. The rover didn't give us any information.
Well, we just don't know.
I guess you're right.
I don't know. If it didn't leave the lander, I don't think it counts. Sojourner to me is still number one.
But so this is absurdly impressive, though, regardless of who's doing it and all these missions talking about. But this was one of a few missions that took advantage of the 1971 launch window. And I was kind of doing some homework this week, including in your wonderful book, The International Atlas of Mars Exploration, Part 1, just the first 5 decades. I discovered that 1971 was really, really busy. We'll talk about the other big mission from 70. It was 71 was a lot like 2020 is this year, with Mars being a popular destination. But okay, 1971, 10 years after the first humans even been to space, we're sending a probe to land on Mars. How do you possibly pick how you're going to land on this small planet quite far away?
Well, yeah, so of course, the information that was available was kind of limited. From my point of view, I'm most interested in how you choose the locations for these things. And so it's worth thinking about what information was available to people. Now, Mars 2 and Mars 3 fly to Mars in 1971, but those weren't the first spacecraft to get to Mars. The Russians had tried to send missions that would fly past Mars and photograph it, or that would land something on Mars. They tried to send them multiple times in the previous years, and everyone had failed. And NASA had tried to send spacecraft to fly past Mars and photograph it before that. One of those had failed as well, but 3 of them had been successful. So the close-up information we had about Mars in 1971, before the new crop of spacecraft got there, it was all from NASA spacecraft. And it was all from spacecraft that just flew past the planet, but took pictures as they went by. So what we're looking at here is a picture that shows it shows part of the surface of Mars. The background image there is from the Mariner 6 and 7 spacecraft from 1969. And then there's you can see some darker patches crossing it, which are filled in more detail, including revealing individual craters and so on. And those are from Mariner 6 and Mariner 7 in 1969. So what we see as we look at those pictures is that in one particular place where we have an arrow pointing and it says Mars 2 target, the Mariner 7 images come down across an area with lots of craters on it. And suddenly, as they move into the area we called Hellas today, they showed absolutely nothing. Really nice pictures, well illuminated, but they showed nothing. They were completely featureless. Now, there are 2 ways you might interpret that. One is that you're looking at a featureless plane, a very smooth area with no obstacles, no hazards. That's what the Russians assumed those pictures were showing. What we know now is that actually it was a huge depression filled with clouds, either clouds of say water or carbon dioxide, droplets or crystals, or perhaps dust clouds. It's not necessarily clear which, but we were looking at basically just a cloudy atmosphere filling in a big depression, but it looked like a smooth, solid surface. So that was the target for Mars 2, and they unfortunately crashed on their way to it. But that's why they chose it. They went right to the place that looked smoothest in the available images.
That's heartbreaking knowing what Hellas is now. It's definitely not a place you would want to land anything.
No, it isn't.
They did hit the planet, though.
It does have the advantage. It does have the advantage of being a huge depression. In fact, the lowest elevations on Mars are in it. So you've actually got more atmosphere for your parachute to work on the way down, which would be an advantage. It's just that you don't really want to go there.
Yeah, it's stormy about 95% of the year. And when it's not stormy, you're fighting the day-night Terminator coming across the basin, and frost from being super cold once you're at that latitude and that time of year. It's just not a great place logistically.
No.
All right.
Well, that's Mars 2.
Yeah, so what did they change up for Mars 3? It looks like it's same general area.
That's the same basic idea. So again, the background image here is from Mariner 6 and Mariner 7. But across it, there's a little line of patches. They don't show up very clearly in this view, but those are the pictures taken by Mariner 4 in 1965. And I want to digress slightly by saying 1965, they had somebody had the audacity to build a spacecraft and put a camera on it and fly it all the way to Mars. Nowadays, we take it for granted that we can do things like that. But 1965, it was an incredible achievement that they could do that. They built two of them, Mariner 4 and Mariner 3 and Mariner 4. And Mariner 3 was lost in a launch failure, but Mariner 4 was successful. It flew past the planet, and it took about 20 pictures, which are marked out there in a line across the planet. They covered a bright area, a dark area. They got down fairly close to the pole, and they were the first pictures to show craters. So actually, these pictures, which we had in 1965, started the process of changing the public's perception of Mars again, which is one of the things we're talking about here, because they showed it to be a cratered world looking a bit like the moon. And some people kind of lost interest in it at that point. Nevertheless, among these pictures, there was a little smooth patch. And I have a picture, kind of a close-up picture that shows that. These are pictures, let me make sure I get this right, pictures 13 and 14 from the sequence. And they're not the actual photographs, they're shaded relief interpretations made by the US Air Force, who were doing the job of mapping for NASA at that time. But they showed quite a smooth area. If there were craters in that area, they would be visible in these images, and they're not. So there's a nice smooth patch, and that is where Mars 3 was directed, and it did land. It landed about 100 kilometers away, something like that, so not right on target, but that's pretty good considering what they're doing here. As I say, we do believe that it actually did manage to land, even though it failed about 20 seconds later. And then there's this famous picture.
Look at that. That's beautiful. You can see the landscape, the mountain.
Yeah, that's right. This is actual video data from the surface of Mars, as we believe. We think that it actually is the real data that was transmitted by the lander in the brief period in which it operated. But there are some problems with it. The first thing is that this was a camera which was going to scan a 360-degree panorama, so a great long strip image all around the lander. But the scan lines would have been vertical. This picture should be rotated 90 degrees so that it's taller than it is wide. That's what it would actually look like. So
everyone can just pick up their screens.
Yeah, that's right. Just rotate your screen there. Really, if there was a horizon visible in this image, it would actually be running vertically on our screen right now because we want to be going the other way. However, there is another little clue as to what we might be seeing here. Mars 3 had two cameras. It was a little spherical lander, and it had two cameras sticking up as little cylinders on top of it. Exactly the same configuration that was used on the moon by a spacecraft called Luna 13 some years earlier. And Luna 13 had two cameras. Only one of them actually worked. And it took its panorama that provided almost a complete 360-degree view of the surface of the moon. But the beginning and end of that panorama were kind of a close-up of the other camera. So basically, the camera that worked starts out looking at the other camera, and then as it swings by, it clears that, and now it's seeing the surface. And that's what we saw for the Luna 13 image. So this is probably the same geometry, and we're probably looking at a basically completely useless picture of just a little bit of spacecraft hardware, if it's really anything at all. And it's entirely possible that this is, although it's probably a real transmission from Mars 3, it may be completely devoid of content, just noise, basically. So it's not clear. But if it's got anything real in it, it's probably just a picture of a bit of spacecraft hardware and not Mars itself.
I like when you said that there might be something wrong with this image. You definitely don't need a PhD in geography to look at this and go, that's not the best data in the world. It's something.
Yeah.
I guess we'll move ahead. So you had mentioned that there were spacecraft missions that went to Mars before Mars 3 and captured those images that Mars 3 and 2 were able to use to plan their landing, their landing attempts. And that's, of course, from the Mariner program. So the Mariner program is incredibly important in the history of planetary exploration. And is it, Phil, would you say, well, Tanya's, maybe Tanya, I'll throw this to you. Do you think it's fair to say the Mariner program is the first real planetary science program with extended science missions, not just these one-off crashes or flybys? This program really had it all?
I would say so. This was a coordinated campaign to try and understand Mars. And we slowly built up from, flying by with 4, 6, and 7 to actually going into orbit with Mariner 9 to try and actually like map out the planet, figure out what's going on. And it's almost a shame because we, Mariner 4 didn't have the best cameras. Like Phil said, we could see that there were craters, and that was really about it. And even though Mariner 6 and 7 gave us better views of Mars, since they were flybys and not orbiters, they were just sort of subject to whatever the trajectory was that took them past Mars. And completely by chance, I don't know if you want to call it that, the trajectories took them past none of the significant features that we know on Mars today. Valles Marineris, the gigantic Tharsis volcanoes, all of the massive outflow channels that empty out into the northern plains that led people to think that there might have been an ocean. They missed all of that. And so we got more views of more craters and, some of the features in the southern hemisphere in particular. But it wasn't until Mariner 9 and getting into orbit that we really started to get the picture of what Mars was really like. And so it was this slow buildup over time.
So we'll talk about Mariner 4, the first one with some decent images.
Decent.
They were incredible for the time. That's
true, yeah.
To remember. It's unbelievable almost that people would have the audacity to build something like that and think that they could get anything back from Mars. But they did.
Okay, so here's a good one then. This is one of the first color images from Mars. Do either of you want to talk about the story of this little bit?
Tanya, I expect you know about this.
Oh, this is basically folks here on Earth waiting line by line for the data to come back from Mars and coloring it in by hand, essentially a paint by numbers, but using real data from Mars. And from what I understand, I wasn't there, obviously, the news media was just like waiting, like chomping at the bit for this to be done so we could see what Mars looks like. It's not incredibly representative of what we know Mars to look like today, but it's pretty amazing that you had people that had the patience to sit and wait for this every little bit by bit as it came down.
Yeah, that's right. So what they actually did here was basically the information is coming back as a digital data stream, one line at a time, at a very, very low rate of transmission. It took about 8 hours to transmit the image, and the image is small and only 6 bit depth. This was, like I said, it was like a miracle that they could actually even do this. So it doesn't do to put it down as a bad image, because it was amazing that they could do it. But it's very, very slow. So as the numbers come back and you're just getting a string of numbers, people thought that they could get their first look at it by doing a kind of color coding. You'd print out the strip of numbers representing one scan line. And then if something was let's say nearly black, you'd color it in dark, and if it was a bit lighter, you'd color it in a slightly lighter shade, and if it was really light, you'd color it in a lighter color again. And so that's what this color coding represented. It was only a monochrome image, but they were using color coding to just mark out the different shades of gray that the image represented, and they would have gradually built it up over a period of time, over, as I say, about 8 hours to get the first image back. And incidentally, what are we looking at? There's a kind of diagonal line, if you like, running from lower left to about halfway up on the right. And below that, everything is brown. That's the sky, and really it would be pretty much black, right? So that's the sky. The line that separates that from the rest of the image is the horizon, or the limb of the planet. And then as we look up above it, we're looking at the surface of Mars, light and dark markings. And of course, you can't see them clearly enough here to know what we're looking at. But in a properly processed version of the digital data, you can see lots of sort of mottled light and dark features. In a few places, you can make out where there might be little craters, but the sun is almost overhead here, so you don't see shadows, you can't see topography. But we can actually find that place in modern images of Mars and see that the markings that's showing up are real features. So it was imaging the surface of Mars.
So the bottom right there, the brown,
yeah,
that space, like
that's space. Yes, that's right.
Yeah, so we're catching okay. Okay, well, I didn't say it was a bad image. I said it was a decent image.
Yeah.
It's very nice. Okay, here's another image.
And this, yeah, so that was one of the most famous images. It's the one that most clearly shows craters. About half of the pictures clearly show craters, and the other half don't really, because the sun was really high in the sky, or the views were very oblique, or the light levels were very low, or something like that. But this is probably the best one for showing craters. We can see craters large and small. That big crater is now called Mariner, in homage to the spacecraft. And what might not be quite so obvious, look down at the lower left corner and then follow a straight line going up until about the middle of the side. There's a straight line. It's a fracture in the surface, a graben, a geologist would call it.
Canal.
So actually, that was discovered in this image as well. The first part of it's part of the circumtharsis fracture system.
Phil's just
I honestly never even noticed that before. That's really incredible.
Yeah, there it is. And you know who discovered that? It wasn't one of the scientists on the mission. It was the science writer Eric Burgess, who was a science journalist who was looking at the pictures. And he said, hey, wait a minute. And then the scientist said, oh, yeah, you're right.
Yeah, I think that could easily be misinterpreted as an artifact because it's such a straight feature, just cutting all the way across the image.
Yeah, it's true, but it's hard to get a diagonal artifact in a digital image like that.
That's true. Good point.
Right, and so that sort of shows these various images around the disk, and then the approximate positions that basically the predicted positions of where they would be on the surface. Now, I've gone beyond that in that book that Danny was talking about to actually find where these are on modern maps of the surface. And those positions aren't necessarily quite right. They never actually did look as far north as that suggests, for instance.
I took this from one of Tanya's presentations, so I blame her.
Tanya.
I just need the Phil Stooke updated version, apparently.
It's all in the book.
I thought I had one of the first image from Mariner 4, but apparently I don't. So we can't cue that up. But so we were talking about Mariner 4, one of the first missions to get these wonderful, amazing, incredible, tremendous, spectacular pictures of Mars. But let's talk about Mariner 9, which is really the mission that redefines Mars for a new generation. The Mars that Tanya and I grew up with.
Right.
Really comes from Mariner 9. Is that fair to say?
Yeah, well, I think that's fair to say. Yes. Okay. I think you are bypassing Mariners 6 and 7, though, and Tanya talked about them, and it really is too bad that they all their best pictures were just of cratered areas. But so where people started out the space age thinking there might be vegetation on the surface, and then they saw Mariner 4 images of craters. Mariner 6 and 7 showed craters as well. Now Mars starts to look a bit more boring. And it was Mariner 9 that turned that around, and in quite a spectacular fashion.
Do you think there was any risk after like 4, 6, and 7 weren't really showing something nearly as interesting as we expected for Mars, that they would just not proceed with a mission like Mariner 9?
Well, I think the sequence of missions was planned and budgeted for, so they probably would have flown them anyway. I'm not sure if they would have wanted to go on and fund Viking if Mariner 9 had just shown Mars to look like the moon. That would be a possibility, but I think Mariner 8 and Mariner 9 were going to fly anyway, and then Mariner 8 was lost in a launch accident again. This is a Mariner 9 image we're looking at here, and it shows lots of clouds.
Yeah, so Tanya, you've talked about this a lot too, and this came up again a few years ago because one of our rovers, one of ours and Planet Earth's rovers was overcome by a dust storm. But a dust storm enveloping all of Mars, it's not the first time it's happened 2 years ago. It also happened when Mariner 9 first showed up, right?
Yes,
yeah.
That's right.
Got to Mars and it was in the middle of a dust storm, and it took quite a while for the storm to clear out because these storms can last for weeks to months at a time. And even once the storm has died down, it takes a while for the dust in the atmosphere to settle out. So the first early images look like this, and they're quite dramatic in terms of the clouds, but they weren't great in terms of wanting to see the surface underneath them. But it gave us a taste of what to expect in the future in terms of Mars weather. And this was sort of the first big storm that we had ever caught there in person.
Mm-hmm. Yeah, and actually some of the first things that did show up in the Mariner 9 images were dark spots in the area called Tharsis, and when they got closer views of them, they turned out to have big volcanic craters in each one. They were the tops of the volcanoes protruding right through the dust storm. So they were the first hint that there was something else going on Mars. Oh, and there's another one. That's a good one. Yes, so lovely picture of a valley with with short tributaries. The other image there shows a lot more tributaries coming into a main channel. The main image there of Nergal Vallis has little short stubby tributaries, which I would say on Earth you see valleys like that mostly in desert areas where occasional flash floods help to carve valleys, but you don't get such an extensive tributary network.
And the view in the upper left is Warrego Vallis, which a lot of folks pointed toward as some of the earliest evidence that we had seen of precipitation on Mars to actually carve this complex tributary system. I know some folks have proposed that Nergal was actually carved by groundwater sapping, kind of headward erosion, more so than surface erosion like you would expect for some of the other carved channels on Mars.
And those stubby little tributaries certainly do give that impression.
So before we get to Carl and Viking, we have a good question here from Meg R. Tanya, if you can you throw that up? Can you cue that up? I will. What is responsible for the creation end of dust storms on Mars since the atmosphere is so much thinner? Tanya, I'm sure you've had this a lot because it's a really good question. How are we getting storms that envelop a whole planet?
It's a good question that we don't necessarily have the whole answer to. You know, on Earth, the largest storms that we've ever seen, I think the largest one is a typhoon, and those don't envelop, even a fraction of the planet. But we can have storms on Mars that regularly get to the point where they take over essentially what would be an entire continent here on Earth. Some of these storms, when they pick up, they become to be like a third of the size of the entire planet, and then they just loft enough dust in the air that it's covering the whole planet, and then that dust sticks around for a really long time. But we're not entirely sure what causes at least the global storms. They don't happen every year, but when they do happen, they happen at the same time of year, kind of like hurricane season on Earth. You don't get a Category 5 hurricane necessarily every single year, but if it's going to happen, it happens during hurricane season, so we can keep an eye out. In general, the storms themselves tend to be triggered by temperature differences, which causes air pressure differences, which we see here on Earth all the time. On Mars, usually this is the case when you have cold air over one of the polar caps or the frost around a polar cap, and then the ground right next to that is ice free. And so that creates a huge temperature difference, and it drives weather patterns along the edge of the polar caps. When we have the global storms, what tends to happen is you have these storms that are hanging out around the edge of the northern polar cap, and they get flung down a couple of storm tracks through topographic lows. One is through Acidalia Planitia, and the other one is through Utopia Planitia, which are gigantic basins. And they tend to fizzle out by the time they hit the equator. But every once in a while, they make it past the equator and then all the way down to the edge of the southern polar cap of Mars. And that's usually the sign that something terrible is about to happen. And then it essentially explodes and takes over the whole planet. That's what happened in the case of the storm where we lost the Opportunity rover, for example. And we have a lot of information for weather on Mars. We've actually been doing daily global imaging of the entire planet from the late 90s with Mars Global Surveyor all the way through today with Mars Reconnaissance Orbiter, specifically to monitor the weather so that we can understand how does it affect the missions we have on the surface, and where do we want to land missions in the future to make sure we don't land it somewhere that's going to get storms like this one, like coming right over it, because that's not good for your missions. But how they get to be the size that they are on Mars is still a little bit of a mystery. And we're hoping that just having these records continue over time and seeing more of these storms and watching how they evolve will paint the bigger picture of, you know, better understanding for how these function.
Awesome. So let's get to something that recently celebrated a anniversary last week, I believe on August 20th or 21st, I guess, depending where you are on the planet. Viking 1 would have been launched 45 years ago that day. And coming up on September 9th would be the 45th anniversary of the launch of Viking 2. And these Viking missions were both an orbiter and a lander, and really the first fully functioning, fully successful landers to go to the Red Planet and advance our understanding of the planet even more. So that's what we're going to talk about for the rest with the future as well. So we see here one of the Viking lander mock-ups back on Earth, a very famous image of Carl Sagan. I used to have a really good Carl Sagan impersonation when I was watching Cosmos the first time, but I think I've lost it, and I didn't want to practice because I'm not sure if my mic was on or not. But that is Carl, Mr. Sagan, Dr. Sagan, with one of the mock-ups and a member of the mission team here. So, Phil, the two Viking landers, they come, well, let's go back to this, and this actually ties in well to the question. Carl Sagan was big about science communication and public interest in science, and this is 1976, so the Apollo program is done. The last Apollo mission of any sorts was a year earlier with Apollo-Soyuz, and the last moon landing was 4 years earlier. So we're kind of, the Apollo mission is done. What is, is there Apollo hangover? Is the Viking mission, it's not human, but it's going to Mars. So does Mars make up for the fact that there's not humans? What do you remember about Viking kind of hitting the press, hitting popular imagination and people getting excited or not?
Well, I think there was quite a bit of excitement for Viking. It was going to do something really quite special, and it was carrying instruments that would have detected living things if there were living things, say microbes in the soil or something like that. So there were quite a lot of sort of expectations what it might do. I think there was quite a lot of interest. The thing is that Mars had passed through its phase of not looking very exciting from the earlier images that just showed craters. And now Mariner 9 had revealed a world of sort of geological wonders, volcanoes bigger than anything on the Earth, giant rift valleys and canyon systems that dwarf anything that we see on Earth. A world of superlatives, enormous channels, and then the channels seem to flow into depressions that you could interpret as dried up seabeds, something like that. So Mars is looking like a really interesting place again. It's sort of been resurrected in that way, and the public view of what might be there. And since we hadn't actually had the Viking results yet, which suggested that there probably weren't things living in the soil, then there's still a considerable expectation that there might be something living on Mars. So yeah, there was a lot of hype. It wasn't at the scale of, I would say, of public interest in Apollo 11, but it might be fair to say that it was the scale of public interest of the last few Apollo landings, which didn't attract as much public attention. But people who were interested were going to be very interested and following it very closely.
Yeah, and it had a cool landing date. I think it was on the exact anniversary of Apollo 11, July 20th.
That wasn't the original plan, though.
Wow. No, it was July 4th, wasn't it?
Yes, the original plan was to land on July the 4th, and not just any old year, but the actual bicentenary of the creation of the United States, I guess. So the bicentennial celebrations were going on around the country. And Viking was going to land on that day. That was the original plan, but they had to delay. And the reason they had to delay was that those Mariner 9 images were enough to show that Mars was a really interesting place, but they weren't very detailed by our modern standards. So although they showed places that might look nice and smooth and safe to land on, they weren't detailed enough to show whether there actually might have been hazards, rough surfaces, smaller obstacles, kind of below the threshold of resolution of those images. So when Viking arrived, the two Viking spacecraft got to the planet and went into orbit, and they used their powerful cameras, much better than Mariner 9's cameras, to do detailed mapping of potential landing sites. And what they found was that the place that they had chosen for Viking 1 to land was too rough. It looked like it had been eroded by the water that was thought to have flowed across the surface, the water from these big channels that have flowed out into a depression. But it made it look like the surface was going to be all sort of eroded, cut into by these flows of water. So they had to look for a smoother place, and it took them several weeks to find a smoother place. And eventually they did, and they chose that landing site and went to it. So now they're landing on the 7th anniversary of the Apollo 11 landing instead of the 200th anniversary of the creation of the United States.
So is the original landing site? Oh, perfect. So was the original landing site close to where they ended up going?
That map shows the Mars Pathfinder landing site, and that is almost exactly where Viking 1 was supposed to land.
Okay.
Yeah. So yes, what they did was they kept looking at places further and further to the northwest until they got to a place that looked smooth enough that they could attempt it. Now that's Viking 1, and then of course Viking 2 is a different story. If you want to look at that as well, there was a lot of argument among the team of people who chose Viking landing sites about where they should be. It had to be a relatively low elevation area. But they really wanted to be in places where there might be water. Now, the Viking 1 site looked like there had been water there in the past. These dried up river channels, dried up seabeds, this sort of thing. It looked like there might have been water there in the past. But people wanted to try to find a place where there might be water now. And the feeling was that you had to go further north. And some people wanted to go very far north, maybe up to the sort of the edge of the winter ice cap. Where they thought they'd be much more likely to find actual moisture in the soil. But that's too far north for other reasons. Well, for one thing, you get into permanent darkness later in the season, and it wouldn't do, for the mission. So they chose an intermediate latitude, but they still thought that there might be frosts or soil moisture there. Actually, that was a pretty good guess. That's why they chose that site. But the point is, they were going further north, and there are several places at that northerly latitude. They're up about 48 north or so. Several places around the planet where you could go, where you have low elevations, and they show up as the darker blue shades in that map. So basically, when Viking 2 went into orbit, it imaged all around that latitude band in the lower areas looking for a decent site, and they couldn't find anywhere that suited them. And in the end, they were getting desperate. They really needed something, and they needed it soon. They chose a place where the place marked VL2 there, Viking Lander 2, which they managed to convince themselves was going to be okay. It actually looked a bit rough, but they interpreted the roughness as probably sand dunes on the surface, and then you could plunk down in the sand dunes and it would be sort of safe to land on. Actually, it was a very rocky site, and it's really quite lucky that they managed to survive landing in such a rocky area.
Yeah, and you can see the entry, descent, landing sequence there for both of the Vikings. And yes, sometimes these landers do land sideways, or, well, thankfully not too often upside down, or sometimes they undergo lithospheric braking, which is saying they crash into the ground. But both the Vikings were successful. So very briefly, because I want to close up on kind of some future identities for Mars, Viking undertook quite a few experiments. Tanya, you sometimes in your public talks may get questions about the time Viking may or may not have found evidence for life in the history of Mars.
Indeed, this has been a controversial thing over time. There were a number of experiments on board Viking, and the most infamous one is called the labeled release experiment. And the layman's description is basically this was an experiment to look for signs of metabolism in the regolith, which is the fancy name for Martian dirt. And some of the parts of the experiment came back negative, but there was one flag that kind of came back positive. And this garnered a lot of attention. But of course, if you're going to claim that you found life on Mars, you need to be extremely careful about the results that you've gotten. And after a lot of scrutiny and looking at what some of the other culprits could have been behind this result, the general consensus of the team for Viking was that this was probably not life. There is a small cohort of folks that worked on the label release experiment who are convinced to this day that they found life, and they will probably take this to their graves. But generally at this point, it's not accepted that they found life. Obviously, or we would probably have a lot more funding for the Mars program, and there would be a lot more excitement going on. But it is worth noting that we've never sent another labeled release experiment to Mars to try and verify these results or do another test somewhere else. And so that's something that the labeled release experiment folks have argued for. And I would say as a scientist, that makes a lot of sense. If we want to see if this was not biological, let's test what it could have been for us to get this result. But there was also some controversy in terms of the results that these same experiments resulted in on Earth when you tested soil from here. So it's a little bit of a muddy story. There's a great book that just came out by Elizabeth Howell and Nicholas Booth, I think it is, a fellow Canadian, Elizabeth Howell,
yep,
called The Search for Life on Mars. And it goes into a lot of detail about this whole will they, won't they story of life on Mars that I highly recommend people checking out if you want to learn more about this.
Absolutely. And this experiment, really interesting design. You scoop up some sand, you essentially burn it, you see what's in the smoke. Very interesting design. Again, if it was positive, if it came back positive, it'd be positive of ancient kind of historic dead life. But of course, as Tanya points out, that's not the most common interpretation. So in the interest of time, let's get to the final question. We've seen Mars start out absolutely fantastical in many ways, quite literally. It's being observed by astronomers. Those observations are being quickly taken up by science fiction writers and exaggerated even further. If you're interested in Mars in the early 20th century and some of the fervor, I highly recommend Maria Lane's book. She's a fellow geographer, but Geographies of Mars. She writes about, Mars is not quite 15 minutes of fame, but its identity as this place where there were aliens and living in a world where there was life on another planet, which is something none of us know what that experience is like. And then Mars became boring in a sense because the mariners essentially showed that it kind of looked like the moon. And then Mars became very interesting again, thanks to Mariner 9 and Viking, and now countless missions afterwards. We know that we don't know a lot, but we also know a lot. I want to ask both of you, in the future, what kind of additional identities, whether it's scientific or social, do you see Mars taking on in the future?
Well, Tanya, you should.
I mean, I think the real change is going to be at this point when humans land on the surface. We've sent fleets of rovers. We have a whole cohort of satellites that are operating there. And I think that we're not going to make that next big leap into understanding Mars until we get boots on the ground. There are geologists that are there to pick up the rocks, look at everything, put everything in context, and really the key is being able to drill incredibly deeply into the rocks so we can really look at ancient Mars and figure out if there was life there or not. It's still going to be hard to answer that question, but I don't think we're going to be able to do that with just rovers where we can drill, a couple centimeters into the surface. So that I think will be the next big revolution in terms of the identity that we have with Mars, which also brings along with it the identity of humans being interplanetary. And so our relationship with Mars will change in that aspect as well. And the fact that that is on the horizon, whether it's SpaceX or NASA or one of the other space agencies, it will probably happen in the next 10 to 20 years that we see humans walking on Mars. And I'm really excited to see how our relationship changes with Mars when that happens, especially in the terms of the general public.
Yeah, I think I agree. Yeah.
Man of few words.
That was easy.
Yeah, excellent. Well, thank you everyone for tuning in. Thank you so much. We'll be doing this again in another month with a rundown of the coming year in planetary science, which is something Phil always used to do for us at Western University at the beginning of the school semester. We would all get to this lunch forum, kind of bring your lunch and eat kind of thing, and Phil would essentially line up the next 12 months of planetary science for us, and it was always the highlight of everyone, because it also was kind of the back to school, how was your summer kind of thing, and of course one of the best talks of the year. So it was always something we looked forward to. We're super psyched to be able to bring it online, so please look forward to that. You can follow Tanya on Twitter at Tanya of Mars. You can follow me at Danny Bednar. You can find Stooke at his website, and you can find all of his Mars atlases there for purchase or through Cambridge University Press if you really want to dig in and become an expert like these two with me. So thank you so much to both of you. I don't know if you have any final words.
No, I guess Phil also has an ebook of MER maps, right? That's available on Amazon.
Not on Amazon, but you can link to it from my website. It's sold through Blurb.
Tanya and I will tweet these things out, and we'll get everyone looking. So thank you so much, everyone, for joining, and we'll see you in about another month.
Great. Okay. Have a good night. Thanks, everybody.
Bye.